solving equations containing rational expressions. In other words, solving equations that have fractions in them. Now, first thing you want to do, that I don't have here, but I should have here, you want to factor anything that needs to be factored in the denominator first, no matter what. And then you find the LCD of all the terms in the equation, both sides of the equal sign, not just the left side or the right side, both sides. Then you multiply each term on both sides of the equal signs by the LCD. When you do that, you will see the denominator start to cancel out. And then you'll continue as you always would as far as solving. Sometimes you may get a quadratic equation that you have to solve by factoring, but that's okay. And then the last thing is, since we're going to have the variable in the denominator, we got to always check for division by 0. So let's just do a few of these and you'll pick up the process as we go. Hardest part, as always, is finding the LCD. First example, let's find the LCD of 3, 4, and 2. Here's what I recommend doing. I recommend writing multiples of the largest denominator, in this case 4. So you think 4, 3 won't go to 4, 8, 3 won't go to 8, 12, 3 will go to 12, 2 will go to 12, yeah, therefore the LCD is 12. So now what you want to do is start multiplying each of these by 12. So I'm going to write it down like this. You can use parentheses, which I highly recommend. It's okay if you don't. Now what I'm going to do, I'm going to write each of these 12s over a 1. And then we're going to simplify each product of fractions that we have. So you can multiply straight across and then reduce, or do what I do and let's reduce first. 3 goes into 3 once, 3 goes into 12 4 times. When you multiply that out, you get x times 4, which is 4x over 1, which is 4x. No denominator besides a 1, and we don't care about 1s. That's what's going on. We're eliminating the denominators. So in that case, we know that 4 and the 2 are both going to 12 because that's what the LCD is. It's what all these would divide into, or cancel into. That's another way to think of it. So this 4 cancels into 12 3 times, and it leaves the plus 21 equals the 2 cancels into the 12 6 times, and it leaves 6x. And now we have just a regular old linear equation that you better know how to solve. And so let's continue on. We want the x is on one side, constants on the other, so I'm going to take the 4x away. Always start, well in this case, take the 4x away. 6x minus 4x is 2x. I'm going to divide both sides by that 2. And we're going to get 21 halves. I know that's the answer because there's no way I'm going to get division by 0 because there's no x's in the denominator. And I'm done. That's the process. Here we go. We're going to do a few more. Yep, you will start seeing variables in your denominator. So let's find the LCD. Start with the numbers. The smallest number that 3 and 6 both divide into evenly is the 6. What's the most number of x's that you have in either place, or in any fraction, or any denominator? Just a single x in either place. So I just need a single x. Now once we have the LCD, what we're going to do with it is multiply each of these terms by the 6x, which is the LCD. Let's take 5x times 6x plus 4 over 3x times 6x equals 1 over 6 times 6x. Now, I'm going to cancel. That's the reason why I have the LCD. That x cancels with that x, leaving 5 times 6, which is 30. These x's cancel, and 3 goes into 6 2 times, so I have 4 times 2, which is 8. These 6's cancels, and it leaves 1 times x, which is x. And then I take 30 plus 8, which is 38. And that's what x equals. If I substitute it back in, there's no way I'm going to get division by 0. So therefore, I'm done with this example. Let's go to another example. This may be a little bit more fun. I don't know. Let's start with the LCD. That's where it all begins. Now, anytime you only have one fraction, that means your LCD is always that single denominator. The reason being because that 2 is over 1, the x is over 1. 1 divides into anything, x divides into itself, so therefore the LCD is x. So I'm going to do the same process. I'm going to multiply the 2 times the x, and the 15 over x times the x, and the x times the x. Now, nothing to cancel here because it's all multiplication, and 2 times x is 2x. These x's cancel, and it leaves the 15, and this x times x is x squared. Now this one is slightly different because of that x squared term, but the process is still the same as far as dealing with the killing or eliminating the fractions. We no longer have any fractions. Since we have x squared, we need to get everything on the same side as the x squared, and the other side should be a 0. So the process is to subtract the 2x from both sides and the 15, which gives us 0 equals x squared minus 2x minus 15. The reason being, we need to factor this x squared minus 2x minus 15. So we can set each of those factors equal to 0 and solve for x. Now when I factor, I don't see a common factor. I don't see 4 more terms. I do see an x squared with no number in front besides the 1. So I'm going to do the full method backwards and do what times what is x squared? X and x. What times what is negative 15? It gives us the negative 2. I know I can't get from 1 to 15, but I can from 3 and 5 if I make the 3 a positive and the 5 a negative. So that's how it factors. And then, since it's in factored form equal to 0, I'm going to use the 0 factor property, or whatever the book calls it, and set each factor equal to 0. Now I'm going to solve each equation for x. So I have x equals negative 3, or x equals 5. Now when I substitute it back in, no danger of division by 0, so both of these are my answers, negative 3 and 5. Well, looks like they're getting a little bit more difficult as we go. That's to be expected though. Let's look at x minus 8 over x plus 2 equals x plus 9 over x plus 1. Now if you want to learn one way that always works, you multiply by the LCD. However, if you look at this, you can always crisscross multiply. By all means, do that if you want to. Highly recommend it. But I'm going to stay consistent and do the same process over and over again. Let's find the LCD. Most of each. This has, the first fraction has an x plus 2, second has an x plus 1. I need one of each. So it's going to be x plus 2 times x plus 1. Now what I'm going to do is I'm going to write down each fraction and multiply each fraction by the LCD, which is going to be x plus 2 times x plus 1. Yep, could be quite a bit of writing here, but that's okay. You do what you gotta do. Now let's see what happens. Over here, these x plus 2's cancel, and it leaves x plus 1 times x minus 8. On the second fraction, the x plus 1's cancel, and it leaves x plus 9 times x plus 2. Looks like a mess, but it's really not. What we're going to do, we're going to full everything out on both sides. So it's full x plus 1 times x minus 8, and we'll get x squared minus 8x plus 1x minus 8. Just stay on the left side. You get x squared minus 7x minus 8. Now let's pull the right side. You get x squared plus 2x plus 9x plus 18. Combine like terms, we get x squared plus 11x plus 18. And now let's solve for x. But notice we have x squares. We need the x squares on the same side. So subtract those off. And you'll notice x squared minus x squared is 0, which means they're gone, which is always good. So now we have negative 7x minus 8 equals 11x plus 18. The reason why it's good is we now have a linear equation to solve and not a quadratic, which would require factoring. This one doesn't. So let's solve these like I normally do, or like you normally do. I always start with the x terms, and I always start the smaller one, which in this case is a negative 7x. I'm going to add 7x to both sides. And then I'm going to subtract the 18 to isolate the x term. And then I'm going to divide both sides by 18 to isolate x. And I'm going to reduce negative 26 over 18. 2 goes in both of those. It goes negative 13 over 9. 2 goes into 26 13 times. 2 goes to 18 9 times. There's no danger at all of division by 0. So that's my answer. That was a fun one, wasn't it?